All right, welcome back to Cruz Learning because it's just that easy with your favorite host, Mr. Cruz. And today I'm going to show you how to use the quadratic formula and how to get complex solutions with the quadratic formula. Now, I'm super excited because this is the one thing that I say that this is the Cruz way. If you get any problem, any type of problem of factoring that says factor or solve the quadratic equations or find the solutions of the quadratic equation, this will always work. This will always work. Let me repeat that. This will always work, my goodness. So you could always use this. This is my favorite part because yes, you learn factoring. Yes, you learn completing the square. Yes, you also learned but factoring by grouping, which nobody uses. I have no idea. I'll have to teach you that, but nobody uses that because you have the quadratic formula. This is the most amazing thing. It's one of the best discoveries in math. Somebody actually worked it out. The proof for this formula, I'm so sorry, is in your math book. I'm not sure if anyone uses that anymore, but you could Google it if you want to. You could go to Khan Academy. You could go to Khan Academy, and they have a video proving that. I'm not going to make a video proving that because it's a little bit tedious and it will take too long, and then I have to do other things. But you're more than welcome to look at the proof so that you know where it comes from. Okay, it's in the book. The book is pretty cool. It's really good. It's very actually it's pretty straightforward with the proof. But I'm not going to do that. I'm going to show you how to use it because that's what is important. And if you want to know, it's 4.7. It's 4.7 in the book. That's where it is. So let's do some things real quick so that you know why do we use a quadratic formula. For example, if we have a quadratic equation, by now I know you know, okay, the quadratic equation is ax squared plus bx plus c. Okay, and if we want to find the solutions or the zeros of this function, we set this equation equal to 0. What that really means is that if we have a graph, okay, we have a graph of a quadratic function. I want to show you this because we're going to start and end with this idea so that it makes sense. We are solving a parabola. This is a parabola, okay? It's a positive parabola because a is positive. And you have three different options. With a parabola. The first option is that you have two solutions. This is the first option. You have two solutions. Okay, that's when we get x equals this or x equals that. Okay, the second possibility is that we only get one solution right there. Hold on, I'm trying to make this to look like a point on the x-axis. That's my one solution because sometimes the parabola only the vertex touches the parabola. And the other one is no solution or complex solutions. And that's when imaginary number comes around because this parabola never crosses the x-axis. But if we solve this equation algebraically, we get two x values. They are imaginary values, but we get them, all right? So they're there. They're there. It's just that they're imaginary. And the cool thing is that we use this to a lot of things. Even the imaginary solutions, we use them for different things. For example, if you are trying to projectile motion, usually it looks like something like this. Let me change the color. Projectile motion looks something like that. For example, if you are throwing a football, anything that you throw up in the air, at the same rate that it goes up is at the same rate that comes down, at the same velocity at any point from the ground, at the same time that it takes to go up is the same time it takes to come back down, assuming that there is constant friction and constant air resistance and all that stuff. Everything is constant. It takes the same time. Also, if you've ever been to Halloween Horror Nights and you go like inside castles or things like that and you see entrances like this, okay, a mathematician had to draw this in the palace or whatever. They have to draw this so that they could actually make it look real, okay, so that they can make it look real. I don't know what the heck. And then people, then you walk through it. Like you walk through it. And you see a parabola shape. A parabola shape. That's when we use quadratic. So let's solve the first one. Example 1. Okay, example 1. Let's say that you have 2x squared minus x equals 4. And I ask you to find the solutions of this. Well, the first thing that you need to do is set this equal to 0. That is the first step. When you have this, and we're going to use a quadratic formula, the first step is to set the function equal to 0. Okay, set this equal to 0. Second step is list list A, B, and C. List A, B, and C. And the second step, third step, use the quadratic formula. Use the quadratic formula. And this is going to look like this, quadratic formula. And here's the quadratic formula. Are you ready? Okay, are you ready? The quadratic formula is x equals, because we're trying to solve for x. We want to know what x is, okay? X equals, here we go. Are you ready? This is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now this equation has so much meaning, so much meaning. It makes life easier, and you will see why in a second. This right here, it's called the discriminant, and we're going to learn a little bit about it at the end of the video. There's a discriminant, and this is, I always remember this, minus b, okay, negative b, you just have to remember that, plus or minus the square root of b squared minus 4ac. B squared is the beach. Who loves the beach? Everybody loves the beach, so we want to go to the beach squared, okay? But when you go to the beach squared, there's a lot of heat because it's during the summer, so you need to subtract the heat with 4 ACs, okay? Hopefully that makes sense. You need a lot of AC units, so 4 AC, so B squared minus 4 AC, all divided by 2a, because you need 2 people to have a great day. Okay, so negative b, all this stuff. Now, whenever you're taking, please write this down. This is one of the most important formulas that you're going to learn this year, and it will be provided to you in the formula sheet. But hey, you need to know how to use it, because there's no point of having a formula sheet if you have no idea what the heck, how to use it. So this is example 1. I'm going to rewrite it over here, and then this is going to go by really quickly. The first thing is set this equal to 0. We know how to do that. We just need to move the 4 to the other side. So 2x squared minus x minus 4 equals 0. Okay, I moved this 4 to this side and I changed the sign. That's it. Or I subtracted 4 from both sides. Whatever makes you happy. All right, now normally you could try to factor this, but instead of factor this, I could use my quadratic formula. Second step says list the A, B, and C. So what's A, what's B, and what's C? Well, give it a try. What's A? A is 2, because it's the number in front of the quadratic term. The number in front of the quadratic term is A. If I go back to my original equation, A is always the quadratic term, B is the linear term, or the x to the first power, and C is your constant, or the number by itself. Okay? Now you have B. B is, now be careful, there's a 1 right in front of the x. There's a 1 in front of the x. So B is negative 1. Not just 1, but negative 1. Because you need to take in consideration this minus. Okay, so if you thought about negative 1, that was perfect. C equals, yep, you got it right here, the constant, which is negative 4. If you thought about negative 4, perfect. Okay, now we're going to plug this into our equation. So here we go. X equals, okay, the first thing is negative b, so minus, and I'm going to plug in b. What is b? B is 2, so I'm sorry, negative 1, so negative 1, okay, and then you have plus or minus the square root of b squared. What is b squared? Well, we just said that b is negative 1, so I'm going to plot negative 1. Now, please do not try to skip these steps, because people who skip these steps is when you commit the most errors. Okay, then you have 4, and you will have to multiply this 4 times a and times c. So what is a? A is 2, okay? A is 2, 4 is, c is negative 4. So negative 4. Okay, let me try to write it in a better way. There you go, negative 4. On all divided by 2a, or 2 times 2, because a is 2. All right, now we can simplify this. Okay, now I'm going to go one by one, so please bear with me to make sure that this is correctly. Okay, negative 1 squared is positive 1. Okay, it's positive, I'm sorry, this is not square. A negative times a negative equals a positive, so this is positive 1. I hope that you see that. I'm simplifying this right here. Now I'm going to go inside the square root, so plus or minus the square root of negative 1 squared is just positive 1. Okay, now I need to multiply all these three numbers. So negative 4 times 2 is negative 8. Negative 8 times negative 4 is going to be a positive. So I'm going to write down a positive, and that is 32, because 8 times 4 is 32. Okay, and this is all divided by 4. I'm almost done. I'm almost done, because then I need to simplify my radical in there. So 1 plus or minus the square root of 33, okay, all over 4. That's it. These are my two answers. I hope that you see that there are two answers over here. There are two answers. One when the square root of 33 is positive. Answer. Oh my goodness. There you go. Answer. One of when the square root of 33 is positive, and the other one when the square root of 33 is negative. So you have 1 plus. I'm going to write it only one time individually. This is 1 plus the square root of 33. Okay, all divided by 4, and 1 minus the square root of 33, okay, all divided by 4. But we don't write them like this. We usually write them in one solution, because we know it's plus minus. Now I need you to realize something. These are you got two real solutions, but these two answers are irrational. These are irrational solutions. The reason why this is irrational is because you have a square root that it's irrational. This is not a perfect square. You don't have a perfect square inside the square root. Okay, if you plug this square root in your calculator, it's a number that will never end. And a number that never ends and doesn't repeat as a decimal, it's an irrational number. So because the square root of 33 is an irrational number, the two solutions of this square function are irrational. When would you get rational solutions? Well, if you would have gotten the square root of 36, that will be 6, and then your answer will be a fraction. That's a rational solution. Also, if you get, like, for example, 8 over 4, that will be 2. 2 could be expressed as a fraction, 2 over 1, so that it's a rational solution. All right, so that was example 1. Let's do example 2. Again, example 2, we're going to use the quadratic formula, which works for everything. If you're taking the EOC, please listen to me. If you're taking the EOC and they tell you use this method to solve this quadratic equation, you don't have to. You could always use the quadratic formula unless there are steps that you need to, they're asking for specific steps. Then you will have to use the method that they want. But if not, if they're just asking you for the solution, my goodness, you could use the quadratic formula. All right, the first thing is set this equal to 0, but this is already set equal to 0. So let's identify A, B, and C. A is 1, B is 6, and C is 9. I hope you see this. I hope you see this. I'm just looking at the signs in front of the numbers. Now let's use our quadratic formula, because we have that x equals negative b, okay, negative b, so b is 6, so negative 6, okay, negative 6, plus or minus the square root of b squared. What is b squared? Well, that's 6. So let me put here 6 squared, okay, 6 squared, minus 4 times A times C. What is A? A is 1, C is 9, and then all over 2A. Remember, you don't have to memorize this formula, because you will have it. You will have it in your formula sheet. All what you need to know is how to use the formula. Okay, so this equals negative 6 stays the same, so I'm just going to leave it alone. Okay, this is negative 6 plus or minus the square root of 36 squared, 6 squared, I'm sorry, is 36, okay, minus 4 times 1 is 4, and 4 times 9 will be 36, and this is all over 18. Hopefully you can see that. 2 times 9, 2 times, hold on, I'm so sorry, I made a mistake, here it is. This is not 9, that is not 9, that's A. So you see one of the common mistakes, please do not make it. That's why I'm making this right here, right now, live. Okay, so the idea is that you double check when you're working on this, so that you see that, make sure that you did not make a mistake. I just realized that I put 9 for A, but 9 is C, is not A. Okay, it's not 1. So my goodness, 9 is C, is not A, so A equals 1. Anyways, hopefully you got it. Now, here we go. Negative 6 negative 6 plus or minus, well, 36 minus 36 is 0. And the square root of 0 is just 0. Okay, so that's kind of gone. You don't have a square root anymore. You have negative 6 equals negative 6 plus or minus 0, but that doesn't really count because that's a 0. So you really have this. Negative 6 divided by 2 is just negative 3. Look at that. You only have one solution. So here x equals negative 3. That's it. That is just one solution. That is one solution. Also, I could have known this. If you have this problem, this is why it's very important that you start seeing things right away. This is a perfect square trinomial. Look at this. This is a square term, a perfect square term, and this is a perfect square term. So if I were to factor this, I could just open two parentheses on the side, set this equal to 0, okay? And then this is squared because it's a perfect square trinomial. X squared, the square root of x squared is just x. This is a plus sign, so plus. The square root of 9 is 3, okay? And if I solve for this, I will have to take the square root on both sides. So I'm going to get that x plus 3 equals 0. So then x equals negative 3. You see how fast I did that because I realized that this was a special case, okay? So if you see and you know the special case, don't do the quadratic formula. Use a special case. Special case are the easiest way to solve a quadratic function, okay? But obviously, if sometimes if it's a special case, and I'm pretty sure they will give you 1 or 2 or 3 problems where they're not special cases, you have to use a quadratic formula. If you want to make sure that you got the right answer, you could use the quadratic formula or use this to double check it. Okay, you have one answer, okay? You have one solution over here. You have one solution. Okay, one solution, and that's it. Those are the examples that I had for you. Now, I want to teach you something. I don't know if you realize, but this right here, it's very special. The square root of b squared minus 4ac. I don't know if you ever heard that math discriminates, okay, but this is the crazy term in math. This is called the discriminant. This is discriminant. One of my teachers says that this math was racist for some reason. It's not racist, it just discriminates, okay? So this is discrimination in math. This is called the discriminant. Why is it the discriminant? I'll tell you in a second. But the discriminant is not other than the square root of b squared minus 4ac. That's what the discriminant, and it shows up in the quadratic formula. Why? The discriminant is very important if they ask you a question about how many solutions. How many solutions. If you have any type of problem that asks you how many solutions, okay? How many solutions, okay? How many solutions do you have? Well, here we go. Are you ready? Because right here, right now, I'm going to tell you exactly what you need to know. If the square root, if the discriminant is positive, if b squared minus 4ac is positive, and actually the discriminant is just b squared minus 4ac, and it's inside the square root, that's what it is. Okay, so if this is positive, and I'm just going to say greater than 0, because anything that it's greater than 0, it's positive. Okay, so if that number inside the square root is positive, you will get two solutions. You will get two solutions. Okay, you will get two solutions. Again, if you go back to the beginning, all the way to the beginning of the video, that's when you have something like this. And your parabola crosses at 2 points on the x-axis. Okay, two solutions. If your discriminant is equal to 0, you get one solution. And when I say two solutions, I'm talking about real solutions. So two real solutions. You get one real solution. Okay, you get one real solution because you could get imaginary numbers, imaginary solutions, but these are real solutions, and that's when you had that one that crossed exactly at the x-axis, but you only had only 1 point at the x-axis. Okay, and if we go back real quick, I'm going to go back to this one. Notice that here the discriminant was 0, so at the end I only had one solution, okay, one real solution. On the previous, in example 1, the discriminant was not 0, it was positive. It was a positive discriminant right there, or right here I should say, so you had two answers. You had two solutions. Okay, so let's go back. Let's go back. There's one example, and it's where the discriminant is negative. When the discriminant is negative or less than 0, there is no real solution. There is no real solution. And that is the first example when the parabola never touches the x-axis. Okay, the parabola never touches the x-axis. So let me write it down real quick over here. If you had it over here, let me use a different color. There you go. It never touches the x-axis. It just keeps going up. And now we have different names for this. All right. You can say no real solution, or sometimes we call it imaginary solutions. Hopefully you don't have an imaginary friend. Okay. Some people do. Hopefully you're not one of them. All right. An imaginary friend, an imaginary solution, or a complex solution. So if you go to your skills tracker, you have some skills that have the word complex in it. It doesn't mean that it's hard. It just means that it has imaginary parts. It has a real part mixed with an imaginary part. So that's a complex solution. Okay, and you get two of these. You get two complex solutions. Okay, two complex solutions or two imaginary solutions. That's what you get. So let me do the last example. Example 3. Okay, if I tell you, hey, you have example 3, and I ask you how many solutions does the equation or the function 2x squared minus 3x equals negative 7 has? Well, the first thing to be able to know what A, B, and C is, you need to set this equal to 0. So 2x squared minus 3x plus 7 equals 0. Therefore, A equals 2. B equals negative 3, and C equals positive 7. If we use the quadratic formula, we get that negative B, so negative, the negative of negative 3, okay, the negative of negative 3, plus or minus the square root of negative 3 all squared, okay, all squared, minus 4 times A, which is 2, times C, which is 7, all divided by 2A, so 2 times 2. 2 times 2. Okay? Now, you could use all this, but you don't need to. I did all this work, but you don't need to. If they ask you to solve the problem, then you need to. But if they ask you how many solutions, the only thing that you care about, are you ready? The only thing that you care about is the discriminant. That's it, the discriminant, the square root of negative 3 squared. Okay, well, this equals, I told you it was inside the quadratic formula. That's why I wrote it down, so you see that. So it takes in consideration when you're doing the solutions. This is 9 minus 4 times 2 times 7. You don't even have to multiply this. I can see from here that this number, whatever that number is going to be bigger than 9, and it's going to be a negative number inside the square root. If you really want to know, this is going to be 56. Okay, and then this equals the square root of a negative number, okay, of a negative number, which means no real solutions. So this one does not have real solutions. This one has two complex solutions. This has two complex solutions. So that's what we wanted to talk about. That's how you use the quadratic formula, two complex solutions, okay? Please get used to using this formula. At the beginning, it could be a little bit tedious because it's the first time that you're doing it. You're plugging in a bunch of numbers, and you have to practice, practice, and practice. But once you get this down, this is easy. It will give you the solution to any quadratic. It doesn't matter if you can factor it, if it's non-factorable, if it's completing the square, if it's by grouping. By the way, this is what I would do if at any point they give you a problem to factor it by grouping. Do not use factoring by grouping. Nobody uses that. Use the quadratic formula, right? So this was Mr. Cruz and with Cruz Learning, and we just learned quadratic formula because it's just that easy.